So either this class or the other class will be flipped upside down. We'll see which one it is later. All right, so this is Math 331, the little questions. If I ever start giving the wrong lecture, just let me know. The purpose of this the purpose of this class is in some sense to justify having the hardest exam in the history of Williams College. All right? The final exam for this class is going to be the Putnam. How many of you have heard of the Putnam? How many of you have heard of the scandals of different schools where athletes have been caught taking classes and doing basically no work or bad work and being passed with high grades? We're going to beat them. All right? I expect we will have people who will get a worse score on the final in this class than some of the athletes got in the work they did in their classes, but we'll end up with a higher grade. I have already gotten permission from Williams to give passing grades to people who get a 0 on the final. Okay? So we'll talk about this in greater detail later, but the final exam will only count for 5%. If you get a 0, that does not count actually as a 0 out of whole 5%. Okay? So it's not going to be too bad. It should be fun. All right. So a couple of things. I want to talk a little bit about the objectives of this course. I am allowed to see what's going on in the monitor, but it's mirror image and whatnot, so it's a little hard. So the objectives is obviously to learn problem solving. How many of you have done math competitions before? How many of you enjoy math competitions? My hand went down. I actually don't really like math competitions. I've been one of the professors who've been coaching the math team for several years. I actually don't really like competitive math problem solving. I know a lot of people who do. Nothing wrong with that. I prefer to use these problems as springboards to get to interesting mathematics. So the goal is to develop problem-solving techniques. These problems are wonderful for that. How many of you have taken a calculus class? Everyone's hand should be up. This is one of the prereqs, right? If you are reading section 3.4 on the chain rule, what do you think will be useful for the problems? The chain rule, yes, excellent, right? There is not that much subtlety in a calculus course in terms of what you should use, right? The higher up you go, especially once you get to research and original problems, it becomes very difficult. You do not know what you're going to need to use. It is a requirement that whenever you teach a class like this, and there are classes like this all over the world, the very first unit you cover has to be mathematical induction. I can prove that. The first school that taught this class did it by mathematical induction. The first N that did it, sorry. If you know induction, that's supposed to be funny. All right? If I give you a unit on mathematical induction and then I give you some problems to solve, what do you think you will need to use for those problems? Induction, yes, thank you. Someone is awake and willing to speak. So there is never any danger for saying something wrong in this class. I only remember good comments. The way I only remember good comments is I overload myself with teaching, such as teaching 3 straight hours straight, then running to lunch, then running to the faculty colloquium at 1 p.m. So I don't have time to jot down notes about what happened in class. Your job is to email me every time you make a good comment in class. And I add it to my file so that when I need to write letters of recommendation, I can write very specific letters of recommendation. I can say things that you have done other than, so-and-so took my class. Their transcript showed the following grade. I confirm. Those letters of recommendation give you nothing. Okay? Speak up. There's only credit for class participation. If you are observant, you might have noticed a jar, or bowl, or whatever you want to call that, a container of M&Ms. By all means, feel free to grab M&Ms during class. And the only rule is every time you take M&Ms, you must speak. Ideally, within that class, worst case, next class. And if you're taking an M&M with 1 minute left to go, I'm not expecting you to make a comment. But it is a commitment to then speak up and participate. I do not want someone to say, oh, I've got 45 minutes of comments I owe you. I'll be doing that the last week of class. Speak up during class. It is a great way for me to get to know you. It's a great way for you to stay involved. I used clickers when I taught differential equations years ago. And at one point, I needed to do something for linear algebra. And I asked the students, I know linear algebra is not a prereq for this course, but I think it's wrong to teach differential equations without doing any linear algebra. You have to talk about systems of equations. Is everybody comfortable with 2x2 matrices? And being Williams students, I got silence or kind of head nodding. And I said, does anybody want to see a review? And so when you put people on the spot like this, do you expect anybody to say, I want a review? Right? I'm sorry?
How much of a review?
You want me to just go over the basics of 2x2 matrices? Is there any questions you have about 2x2 matrices? No response. I said, okay, let's use the clickers. I will not report what, I will not tell you what the answer is, what the response is, but I'm just curious, how many of you would like to see a review of 2x2 matrices? I never promised I wouldn't tell future classes. 43% of the class wanted to see a review of 2x2 matrices. I was younger, I looked much more like an ogre back then, I've mellowed in my old age, well, middle age. But 43% is a significantly higher number than 0. Okay, if you have a question, almost surely you are not the only one who has the question. In a class like this, it's a very strong likelihood that it is the grader, TA, and myself who also have that same question. These are extremely difficult things in terms of finding the right way to look at them. I will not know all the answers. I would not pass the final myself. Okay? But if you don't speak up, it's not going to help. So please, speak up if there are any questions. Okay, so obviously we want to learn problem solving. I want to emphasize techniques and the importance of asking the right question. So when you're looking at these problems, one thing sometimes is, can I solve this as an induction problem? And again, when you're doing things in the real world, you're not lucky enough to have someone come up to you and say, this is an induction problem. You have some problem that you encounter. The more experience you have, the better sense you have of what I can try. The other thing is you will master certain types of techniques, certain types of estimates, certain types of inequalities, certain types of inductive proofs and whatnot. And the more of these you know, just try them like a laundry list. Let me try this. Let me try to think of it as an induction. Let me try thinking of it like this, like this, like this, like this. And hopefully one of them works. And just putting yourself in the mindset, let me view this as an induction. So I want to get you to the point of expertise in solving a variety of problems. And that is a skill that will be transferable. Any of you planning on becoming a professional math competition taker? Yeah, no, it's not such a thing. So for those of you who are you're planning on turning pro?
Oh no, just like actuarial exams.
Actuarial exams is different. But is anybody planning on a professional career taking math competitions? If so, for those of you who that was your plan, I'm sorry, it doesn't exist yet. If you've ever seen the TV show Sliders, there was an episode of an alternate Earth where that was a possibility. But in our world, we instead have football players, baseball players, tennis players, stuff like that. So not going to happen. But the ideas behind solving these problems, the methods used, will be useful for a variety of things. And again, that's the key thing here. This is a springboard. So for those of you interested in actuarial exams, how you think about these problems, that's going to be a very transferable skill. Okay, what else? So I want you to learn how to use computers to build intuition. How many of you have not programmed at all on a computer? Okay, I want you to learn how to write very simple code. It can be in Mathematica, MATLAB, R, whatever you want. It's not that hard. Later I will give you some links to where you can go to learn how to do this. I used to tell everybody if you could take a probability course, a stats course, and a computer science course, you will always have a job. You might not like it, but you will have a job. Anybody who's had me before know why I no longer say this? Yes?
Well, there was a recent lawsuit of graduates.
Yes, very good. Excellent. Email me. Somebody sued their institution because they did not get a job when they graduated. And because of the Freedom of Information Act, you can actually download their lawsuit, and you can see they misspelled words like tuition. And they argued that they were being discriminated against by their school because their school put an undue emphasis on grades and did more for people with a higher GPA than a lower GPA. And their 2.6 was just as good as someone else's 3.6. So I will no longer promise you jobs, if you master these 3 subjects. That said, you will have very marketable skills. You want to learn how to write computer code to get some idea of what's going on, to look at some special cases and build intuition. There's a great website called the OEIS, the Online Encyclopedia of Integer Sequences. And it has all these great words you want. It has encyclopedia, and it has the word online. And it's wonderful. You put in a sequence of numbers, and it will tell you all the places it knows where this sequence of numbers is a subset, either adjacent or just somewhere in that order. How many of you have done proofs by induction? Okay, if you're trying to prove things by induction, it's nice to know what you're trying to prove. That makes things a lot easier. If you want to prove the sum of squares is a cubic, or the sum of the first powers is n plus 1 over 2, if you know that, it makes things a lot easier. You can use the online encyclopedia often to guess what the answer is and what you should try to prove. Now, of course, on the Putnam, you're not going to be able to do this. But in life, you will be able to use resources like that. All right, so as I've said many times, using these problems as a springboard, also to uphold the honor of Williams in math competitions. We are, I believe, the only school that will announce at a football game whether or not its math team has won a math competition. So every year we play Middlebury. And Dick Quinn in athletics was asked, why the hell do you care what the math team does? And I love his response. It symbolizes the great community we have here. And he said, if you keep score and Williams is mentioned, I care. So not only will the score of the green chicken contest between Williams and Middlebury be announced at the football game that day, they will announce it on the athletics homepage. If people want to see about getting jackets and stuff like that, I'm game. We can investigate something like that. Really intimidate Middlebury as they come in on campus, because we're hosting this year. You will not find another school that will do this. We actually reciprocate, and I will announce big victories of Williams' athletic teams on the math homepage. And so in fact, we will announce when we win the Directors' Cup. For the most part, I just put up an announcement every year. We do pretty well. Okay. So here is a picture of the green chicken if you have never seen the green chicken before. The original story was it was not clear whether or not the winner or the loser of the Williams-Middlebury contest gets the green chicken. It was an unwanted wedding gift many years ago to one of the faculty at Middlebury. And because of Dick Quinn, the Boston Globe did a story on this. You can actually see this in one of the cases on the second floor of the math stats department. And one day I get a message from somebody in central Massachusetts. And they said 40 years ago when they got married, they were given a ghastly brown chicken. You know, am I interested? And I said, I can be there on Friday. And so I drove to Central Mass, took my son. My wife was teaching in Boston, so we just continued on to Boston. Wasn't that much out of our way. We now have Brownie. Brownie is actually my individual personal property. And I have promised to give Brownie a good home. If we lose to Middlebury, the green chicken goes to Middlebury. If you have gone to colloquium and enjoyed the cookies, the green chicken is responsible for bringing out the cookies. If we lose the green chicken, there may be no cookies this year. Now, Brownie, in the past, has been pressed into active duty and has delivered cookies successfully for a year, but it's not something to count on. Okay? So you will all be taking the green chicken exam. Okay? The date has yet to be determined. If you are not able to do it because it is a Saturday, you will just take it at some other point. Okay? But ideally, you will try to take it during the competition. We had over 2% of the campus take the Putnam last year, which is unheard of to have that high of a participation rate. The Putnam will be your final. More on that later. I want you to be a little bit terrified and have that, stirring in you for a little bit. All right, course mechanics. Homework 42%, hopefully you know why. Midterm is 30%, that's the green chicken exam. The final is 5%. You can actually get above 100% on the final. If you solve a lot of Putnam problems right, I am happy to have that count more. How many of you are considering grad school in mathematics? A couple of years ago, one of my students had a mediocre GRE score, not a great, not a horrible, and a grad school was very concerned. It was one of the few times a grad school called me up and they wanted more information about someone. Now, I had already said what I'm about to tell you in their letter of recommendation, but schools are just flooded with information and they had missed it. I said, well, he took the Putnam and he was either in the top 500 or the top 250. And at that point, they were like, fine. They were no longer worried about the GRE score. They had a good measurement. Right? So if you are interested in grad school, a good Putnam score can actually go a sizable way in terms of your graduate application. All right, so the prereqs for this course is just linear algebra. It would be nice if you knew analysis. It would be nice if you knew programming. But I'm not requiring those. I'm also not requiring algebra for two reasons. One is I'm an analyst, and two, I've never taken algebra myself, and I don't really think it's fair to require you to do something I would not do myself. So I will tend to do algebra problems from an analytic perspective. It's painful to watch me do these algebra problems. So hopefully some of you in the class are more algebraically minded than I am and will know better ways of looking at these. Office hours, whenever I'm in my office, it's office hours. Please feel free to drop by. In previous years, I have had a policy that you cannot find a 3-hour window between 9 p.m. and 7 a.m. when I will not respond. I may have to go to 4 hours due to health reasons. I'm getting older. But I am very good at responding to emails. If you have questions, shoot me an email. You should also be talking amongst yourselves. I do not use, for the most part, Glow or any of the resources that OIT offers. The reason is they keep changing the resources they offer, and they keep changing the program, and they keep having these new faculty training sessions to get you to use the new things. And I just hit delete and smile. I just do my own HTML code directly. And yes, my web pages do not look nearly as professional, but I don't have to worry about any of these issues as they adjust things. And when I go on sabbatical and I teach at other places, or if I want to pull things from class to class or across schools, it's very easy for me to do it. But if you want to have a discussion group for stuff like this, if you want to have a blog, a web, some place for you to put things so that you can all talk to each other and do feedback, absolutely happy to do something like that for this course. We can either do that through Glow or through something else online. You guys are almost surely better informed at stuff like this than I am. If somebody wants to take point on that, just let me know. Other thing is, you can email me anonymously at efsmath@gmail.com. The password is the first 8 Fibonacci numbers in the standard way of defining them, 0, 1, 1, 2, 3, 5, 8, 13. All I ask is you not change the password. You would think this would be obvious. All right, that's why it's no longer Math3. Okay? Obviously, the closer your question is to Math331, the more effective I will be at resolving the issue. But by all means, feel free to email me if there's something with this class, with the department, with the college, with America, with the world. The further out you go, the less likely it is I will try. When I was at some institution, one day 3 students came to my office and asked if they could talk to me. And I said, sure, and they closed the door. And I apologize for those of you who've heard the story multiple times. It's never a good sign when students come to your office and want to close the door. I think last time I said, it's usually not, I just won the lottery and I'm thanking all the professors who made a difference in my life. I said, okay, well, what's the problem? And they said, well, we're supposed to be in group theory. And they just paused and said, okay, well, then go to group theory. Why are you in my office? And they said, well, the professor's not teaching group theory. What's he teaching? He's teaching Galois theory. What? He prepared the wrong class over the summer. Did you tell him? Well, what did he say? He said, well, how much group theory do you need to know for Galois theory? I'll teach you the group theory you need to know in a week and we'll do Galois theory. Now, there are defensible reasons why you would want to do Galois theory quickly, and you can skip a lot of group theory and get to Galois theory. But this was an issue where they did not really feel comfortable telling this professor, please teach the subject you're supposed to. Okay? If there are issues, please bring them to my attention. We have a much better chance of resolving issues if you bring them to our attention than if I'm just trying to look at people's faces. Okay? And so, again, it can be about this class, it can be about other things, and then, you can tell me how you want me to respond. Easiest way is for me to just respond back to the same account, and I can just send an email to efsmath, and you can just read it there. Okay. So web pages, there's going to be a lot of resources on that. If there are things that you want, if there are things that would make this class easier for you, if there are things that you're interested in, let me know. I'm happy to try to work that into the class, work that into the web page. There's opportunities to help write a book. So I am very big on broader impact to the mathematics community. There's lots of different ways this can take. For those of you who are thinking of graduate school, this is especially important. You should be applying for National Science Foundation fellowship. These are, in some sense, a free pass to graduate study. And you can go up to a university and say, greetings, I'm sorry to bother you, but I, in my NSF fellowship, just wanted to check and see where am I on your wait list. And you'll often get a response like, what a coincidence. We were just about to email you and your newly awarded NSF graduate fellowship to inform you that you are no longer on our wait list, and we would love to have you in your NSF graduate fellowship, which will pay for you to come to study with us. So it's often a free pass to get into institutions. Even if you do not get it, the more people who apply in math, the more fellowships go to mathematics as opposed to other disciplines. It's also just good practice to apply for something like this in terms of writing these up and getting a good thought about what do you see yourself doing with your life. But one of the big things they care about is broader impact. And there's lots of things this can be. This can be talking to other people about mathematics, going into schools. Another thing can be service to the mathematics community. So I am the problem editor for Pi Mu Epsilon, the Undergraduate Math Honor Society. And we've basically just celebrated our 100th anniversary, and I thought a fun way to celebrate this would be to have a list. Everybody likes to have lists. And so I thought, let's have one entry for each year about some key mathematical event that happened. Now, I had this idea when I came on board as the editor, and the first issue was due in 2 months. And that was not enough time for me to do 100 things. So I'm trying to farm out some of the problems. So I've broken up into congruence classes modulo 4. The first 50 have been done. The next 25 is mostly done. The last 25 needs a bit more work. So if you want, there's a bunch of years left. I've got ideas for topics for them, and the idea is to just read up a little bit about them, write a short little blurb about why this is an important mathematical topic, and then come up with some problem. And the problem may be open, it may be resolved, it may be a standard result. And these will be published in the Pi Mu Epsilon journal. Also, the MAA has decided that they want to turn this into a book. So we would expand a little bit on the write-ups for the Pi Mu Epsilon and talk a little bit more about putting things in context. And I think this will be a really nice resource for people to try to get a sense of what is going on in mathematics. Now, whenever you do lists like this, there are a couple of items that are just obvious no-brainers you've got to put in. So if anybody does anything in cryptography, RSA, this is a seminal event in mathematics history, that goes in. Paramin's proof of the Poincare conjecture, that goes in. Other things, you have a lot more flexibility in terms of what goes in and what doesn't. And a lot of times the decision is what's accessible. What would students like to read about? What will give students a good idea of what's going on in mathematics? So if people are interested in something like this, I think this is a great thing to do. It's a good way to not just solve problems, but actually to come up with problems. I maintain a math riddles page. And so if you Google math riddles, it's usually one of the top hits in the world. This is used by high schools, elementary schools, junior high schools all over the world. We typically get at least 4,000 distinct hits a month. I have a lot of correspondence with teachers who want to use these in their classrooms. So one thing to do is to try to solve some of these riddles and keep track of all the false attempts you had, and then write up a study guide for teachers who want to use this in their classes. So I have a couple of problems that I've already done. We'll discuss some of these in the class. But if you want to do some more of them and help make this webpage even better, that would be terrific. And again, this is a great example of broader impact that you can have. These are already being used all over the world. The more information we provide on these riddles, the easier it's going to be. There are some riddles where I really do not care about them. They're very similar to math competition problems. But the ideas behind the solutions are often outstanding. And these become a great way to bypass some of the rigidity of Common Core and actually get some good mathematics in at a quick, easy way. I've got to be very careful about saying that on the web, but oh well. All right. So here is some advice from my brother. So he has distilled what he has learned in college into 3 bullet points. The first is party less than the person next to you. The first time today, there was only one person in the first row, and so that person was in trouble. Everybody here has at least one neighbor. You are here to work. I will do my job. I will assign plenty of work to you. Right? Your job is to do it. Right? Second one is take advantage of office hours and mentoring. One of the wonderful things about being at a small liberal arts college is the professors are accessible. I was at an institution where a professor had office hours 8:30 a.m. the day after homework was due. Why were office hours 8:30 a.m. the day after homework was due? Because then no one would come, right? There's not been enough time to really look at things. And it's sending a clear signal to the students, don't bother me. And the students got the message. Right? This is not Williams. I have sent public safety after someone to make sure they graduated and fulfilled a requirement. It's kind of fun to be able to say that. This is a small college. We don't like people to fall through the system. The rest of the world, the rest of life is sadly not like this. And again, it doesn't have to be me, it can be other professors. Take advantage of the resources while you're here. Take advantage of talking to each other. Take advantage of the professors. The last one is learn how to manage your time. This is extremely hard. The first time I taught an upper level class at Williams, one of the complaints I got is I only had homework due every 2.5 weeks. And someone wrote on the blue sheets, this was too much homework. They start the homework a day or two before, and there's too many problems. And I had done this because most of them were seniors. They were visiting grad schools. They were going on job interviews. This way they could manage their time. You would think after 1 week of too many problems to do at the last minute, they would realize by week 2, homework assignment 2, homework assignment 3, homework, at some point you think they would realize, start doing the problems in advance. Learn how to manage your time. Get ahead in the reading. Build up a strategic reserve. Read ahead. Start homework problems the day they're assigned. There's going to be some really tough ones here. I remember when I was in college, I would sometimes get together with friends outside of the sciences. And it was always interesting. When are you going to be free? And my friends who were history students, they knew how much they had to read. They knew how much they could read an hour. And they could tell you when they would be free. I'm doing my math physics problem sets. I need 2 clever ideas. I have no idea how long that's going to take me. And so math is extremely different in terms of how long it's going to take to get some of these things done. There's going to be a lot of work. I hope it's going to be fun, and I'm happy to take suggestions from you as to what you want to see. But you've got to stay up on the work. Okay. Now for some things like the Putnam, it's not going to really matter. For the most part, most of the studying you do for the Putnam, maybe it's going to help on one problem. Just trying to keep that fear of dread looming. Okay? All right. So I'm happy to do practice interviews or to adjust deadlines accordingly. Are there any seniors here? All right. What is your most important job as a senior? Get a job, get something after college. Right? Bill Gates, I don't think, graduated. He did quite well. So your job is to get a job. Now, along the line, you hopefully will also graduate from Williams. Usually those go together. But your top priority is to get a job. If you have a big interview coming up, you want to be prepared. You want to know stuff about the company, or you might be flying. I am happy to adjust deadlines, around stuff like that. Just let me know with as much warning as possible. Okay? All right. So some useful links. So here is a link to a web page of mine where I have templates on how to write papers, posters, talks in LaTeX, as well as a template for Mathematica. I also have 2 videos there about how to use the systems. It would be obviously wonderful if you were all experts in both of these by Monday, but we're not going to need that material as fast as Monday. But these are really good skills. Is there anybody here who is not a math or stats major? Okay. So either everybody is, or again, it's like that 43% that I'll find out about later. These are skills you really want to have. You want to be able to write scientific documents. And for the most part, that means doing things in LaTeX. It's not that hard to learn most of LaTeX. So in about half an hour to an hour, you can learn about 99% of what you need. If you know what the snake lemma is, you might have trouble formatting something like that, with that quick introduction. But most of what you need to do, you can learn in an hour. Similarly for Mathematica, you can pick up a lot of it very quickly. And once you pick this up, you can actually write some simulations and get a sense of what things are like. All right. So we have about 20 minutes left over right now. So the question is always, how much do you want to do on the first day of class? And so I've been babbling about course mechanics. This is now the 3rd time in a row. I'm going crazy. Okay? I'll do a little bit more babbling, but I actually want to do some math today. It's getting frustrating. So you guys luck out. The last thing is, I forgot to mention this in the last class, this is a partial democracy. When things don't matter, you have a vote. So you get to choose the cell phone policy. Option A, first time someone's cell phone goes off, the whole class is warned. And the second time someone's cell phone goes off in the semester, everybody has a pop quiz the next day. Option B, if your cell phone goes off, you have to bring Dunkin' Donut munchkins and something healthy or the equivalent to class the next day for everybody.
That one.
Yeah, that one.
So motet be. All right, so the cell phone policy is that if your cell phone goes off, you are responsible. My cell phone is 617-835-3982. I will email you that. If you ever want to test and see if my cell phone is on or off, you're welcome to try. You may have friends outside of class try. But along these lines, if you are expecting an important call, family members in the hospital, you're about to find out if you have a job interview, don't have your phone on silent. Let me know, and you're off the hook for that day. You don't want to miss getting a call. That said, I don't know if you actually get reception in this room. And so, if somebody actually wants to try calling me right now, it'll be interesting to see if we actually have cell phone reception this far down. This is one of the few classrooms which cannot be used during a power outage. So last spring there was a Friday when there was a gas leak in Bronfman, and there was some power issues, and they said anybody whose classroom does not have natural lighting, class is canceled. That's us. Okay? We're, I think, the only class that actually fits in that category. The reason we have this classroom is when I went on sabbatical a couple of years ago, Williams told me they couldn't store my stuff. And after I'd moved a third of my stuff home, they told me, oh no, we can store things. And when I came back from sabbatical, they forgot where they put my stuff. So I was going through the building with buildings and grounds, and eventually we came to this room, which was being used as a storeroom, and we found my stuff in a corner. Wait a minute, why aren't we using this as a classroom? We don't have enough classrooms that can handle 40 or so people. And so that is the reason that this class is back in circulation. It's, I'm sure, entirely coincidental that I seem to be getting this classroom significantly more often than all of my colleagues. But again, if anything is going on, and this is a dangerous world, we are safe. Okay? Any questions on the class mechanics? Yes?
Do silent cell phone ringing count?
No, if it's on silent, it does not count.
Okay.
Any other questions? Yes?
What about vibrate?
Vibrate is fine. And again, if there's an important call, if every day you're expecting an important call, I want to see some documentation of this. Other mechanics questions. All right, so we can either do Pascal's triangle or we can start off with induction. Pascal's triangle. Excellent. Good choice. Okay. So let's see if this will work. Okay. So here is Pascal's triangle. Right? And again, I don't mind putting people on the spot. How many of you have not seen Pascal's triangle before? Right. This is one of the standard prereqs that everybody goes through at some point in their life. There are all fascinating properties of these numbers. These are the binomial coefficients. In terms of math problem solving, these occur all the time. So can somebody give me an interpretation for 28? So first of all, this is what? So in Pascal's triangle, this would be what? How would I call 28?
7 plus 21.
Well, it's 7 plus 21, but how would you say this?
9 choose 3.
Not 9 choose 3.
8 choose 9.
Nope.
8 choose
8 choose 2. 8 choose 0, 8 choose 1, 8 choose 2. Since we see the 8 here, we know this is the 8 row. The one over here is the 7 row. The one down there would be the 9 row. What does 8 choose 2 mean? Good. It's the number of combinations. It's the number of ways to choose 2 people from 8 people when order doesn't matter. Think representatives in student council. Does it matter which building you represent? Or which block or whatever? No. What if we're talking about offices? Is there a difference between being president and vice president? Yes. One vice president famously described his job as "you die, I fly." And that his job was to basically represent America and express our condolences at funerals. For something like that, you would not do 8 choose 2. That's something where order matters. But the binomial coefficients, these are unordered. Another nice way of looking at these, and we'll do far more on these binomial coefficients, is this is x plus y to the 8. And as you expand it out, these are the coefficients you get. This is the coefficient of x to the 8. This is the coefficient of x to the 7th y. This is the coefficient of x to the 6th y squared, etc., etc., etc. And there are lots of ways you can prove these numbers have these properties. One way is by induction, right? This is a class where we're supposed to be doing induction. I'm in trouble if I don't mention induction at all in the first row, in the first day of class. So one thing is, if you have an interpretation of these, to use induction to prove that the interpretation holds for the next line. So we'll do a little bit more induction formally. But what I want to do is I want to try to show you some interesting properties of Pascal's triangle that you may not have seen before, just so we see some fun mathematics. All right, so somebody has already remarked that 28 is 7 plus 21. And this is a nice way to quickly generate Pascal's triangle. You take any 2 numbers and you sum them, and the number in the next row between them is their sum. You could create your own triangle where you have different rules. And then you could ask, what kind of sequences would that generate? What could you do instead of adding?
Start off with something more interesting and multiply.
You can start off with something more interesting than multiply. If I start off with 1, 1, 1 and use multiplication, I would get a triangle of all ones and it would be quite boring. But maybe I start off with 1, 2, 3, and then I start doing multiplications. Now if you do that, you're only going to have things that are going to be powers of 2 and powers of 3. But this is one of the big things. Create questions. Come up with your own triangle, where you have your own rule, your own combination. What if you do subtraction? What if you do some kind of interesting combination? Maybe you have some function of 2 variables and you evaluate it at those. And you create your own triangle. Which triangles are interesting? Now in a math competition, I could easily create a problem like that where I give you a function of 2 variables x and y, and this value here is f of this comma that. And then ask you properties of that triangle. That'd be a great way to create problems for the green chicken or something like that. I am in charge of writing the green chicken exam this year. The exam was written sometime last semester. I have no idea anymore what's on the exam. And I had to, in terms of managing your time, I have to do this so I do not accidentally give away things that could be of use to the green chicken exam. But that would be a great way to create problems, is take something that you've seen and tweak it. And maybe there could be something interesting that you find, maybe something universal. So when you start seeing this, the first thing you should be doing is you should be looking for patterns. So this is a class on problem solving. Step 1 is always, do you see any patterns? Do you see anything interesting? So there are some patterns that are blatantly obvious and screaming out at you. What's the most obvious pattern you see when you look at Pascal's triangle? Okay, the ones going out like this. Okay, good. Next obvious one. Yes?
As you start from the third line and go
Yep.
down, it's 1, 2, 3, 4, 5.
Good. Just the integers going up in straight order. Excellent. Yes?
It's symmetrical.
Excellent. It's symmetrical. What else? All right. Should we see some new interesting properties of Pascal's triangle? I vote yes. Okay. So I'm babbling right now. The link is there. You can listen to the link at some point. What we could do is we could look at Pascal's triangle and look at the numbers mod 2. And mod 2 basically means, is the number even or is the number odd? And when you start looking at Pascal's triangle, do you notice any patterns of even or odd? And so what I'm going to do is I'm going to generate Pascal's triangle. I'm going to actually rotate it 90 degrees. It's just easier when I was writing the Mathematica code to do things like that. I then have things as a function of x. And so here, what I'm going to do is I'm going to be doing Pascal's triangle. I'm going to keep adding rows. And as I add the rows, I am going to put a dot if it is odd and have a blank if it's even. And so this is looking at Pascal's triangle on its side, adding more and more rows. I will not even ask if anybody sees a pattern on this one. Okay? So how many of you have seen this pattern before in Pascal's triangle? Okay, do you know what this shape is called? Sierpinski's triangle. I actually used this when I was doing the Latke-Hamantashen debate last year to great effect. And so here, this is incredibly rich structure that's going on. What do you think are natural questions to ask?
Mod n.
Oh, so great. One thing is, well, what happens if I do things other than 2? So that's one question, is what would I get if I looked at things mod 3, mod 4? What else could I ask? Yes?
Like interactions with rows, sums of rows.
Interactions with rows, sums of rows. So the first thing is, does everybody agree that there's a pattern here? So now that you've identified a pattern, the question is, can you prove it? What do you think might be useful to prove this? Induction, right? Without a doubt, just say induction today, and you'll be correct. When I teach Calc 3, my students have learned that 90% of the time when I say what would be useful, the answer is linear algebra. You're right. Induction is not bad, especially today. If you look at this, I have some shape, and then I'm somehow showing that the thing expands and combines. And so now I will see if I've got to be careful because I've got to fool the camera as I turn around. Is it working? All right, so here I have something over here, and now I have 2 copies over here. Can I somehow prove that this copies to these 2 things here? Then I have this whole block here, which copies to this whole block here. Then I have this whole block here, which I want to prove copies to those blocks there. So hopefully you can begin to see the bare bones idea of how you might make this argument rigorous. So again, as a fun thing this weekend, try to prove by induction that this pattern will continue. Now let's think about what's going on. I have this long row of even numbers here. I always have odd numbers at the end. When I have 2 even numbers, what happens when I take their sum? Even. So if you have 6 consecutive even numbers, what's going to happen in the next row? So I have 6 consecutive even numbers. I'll go high so it's being recorded. What happens in the next row? 5. You can do a little bit better than 5, at least 5. Maybe I had more than 6 consecutive even numbers. But however many even numbers I have, if I have n, then the next row will have n minus 1. Well, I know I have to have odd numbers at the end. So if I have an odd number at the end, what's that going to do when it hits the even number? It's going to be odd. So that's going to give me these strings of ones on the sides. But then maybe it's also going to somehow be filling in. And maybe you can somehow see by an induction what's coming up. What you can do is you can keep rescaling the triangle to take up the same amount of space. And that's what I'm doing over here. So it's not going all the way off to infinity and becoming this arbitrarily large super triangle. This is actually a fractal shape. Its dimension is somewhere strictly between what and what? What would you guess its dimensions between? I think you might have said it. Greater than? Greater than 1, less than 2. So if it was greater than 2, it would somehow have to be going up into 3-dimensional space. We can do 3-dimensional versions of Sierpinski. This one is somewhere between 1 and 2. Any Star Trek fans here? Okay, anybody a fan of the new Star Trek movie? I'm sorry, the new movies that have Star Trek in their title? Good. And so, I'm a big fan of the original Wrath of Khan. That was the first instance, I believe, of fractals being used in a movie to simulate the Genesis torpedo and the landscape. And so there's a lot of great applications of fractals. There is an enormous wealth of stuff going on here. And so one thing for you to do is to try to figure out, can you prove that this pattern persists? How many of you are considering something applied with your life? Okay. Is it okay to wait 6 years for computation? No, in general, no. There are very few things that are worth waiting 6 years for. Somebody has completely solved checkers. It took them 20 years to have the computers go through everything. Now, I believe they could do it much faster than 20 years now because the computers have been getting better and better and better. And there are some things you can just have running in the background, and you can take a couple of months. When I was younger, there was a huge drive for people to have their screensavers actually working on computations. There was the SETI search for extraterrestrial intelligence. There was the Human Genome Project. There was the search for Riemann zeta zeros. You could have these problems just running on the background in your computer. The great internet Mersenne prime search. People would parallelize tasks and have computers running away. And it would often take years before there was a hit. But we could afford to do that. For something like this, is Pascal's triangle hard to compute? So I'm seeing yeses and nos and some from the same person. Is Pascal's hard to compute? And if that question is too difficult to answer, I will rephrase. Theoretically, is it difficult in principle to calculate Pascal's triangle? No. All you have to do is n choose k. N factorial over k factorial, n minus k factorial. Not a problem. In practice, is Pascal's triangle hard or easy to compute? What do you think?
Hard.
Hard, right? Probably a good chance that that's going to be the case based on the fact that I'm asking you. My favorite exam question was when I was at Brown. I was teaching abstract algebra. Just because I haven't taken it doesn't mean I can't teach it. And I asked them a question, is the following set a ring? And that was worth 5 points. And then part B for 15 points, was it an integral ring? It was not a ring. It failed closure. But it was amazing how many students wrote, it must be a ring, else why would you give us part B for 15 points? Very easy to be misled and to put preconceptions. You want to be very careful about something like that. We just think naturally, oh, this is not going to be difficult to calculate, it's just n choose k. N choose k can be very hard. So, things to think about, and we can talk about this later if people are interested. How would you efficiently calculate Pascal's triangle? The reason I wrote the computer code to do this is, I was trying to find fun math for my classes and for my kids. And I wanted to just show, Cameron and Kayla, I think this is now time for the obligatory picture. Have I shown them yet today? All right. So this is not the best picture of them because Kayla's really covered by a lot of things I need. But this is for something that we'll be dealing with later in terms of problem solving. So I actually needed them on the boat. We brought them back safely. But I was looking for things to keep them excited about mathematics. And I wanted to show them Pascal's triangle. I wanted them to see the fractal structure emerging. And I couldn't find a good video on the web that showed the triangle being built row by row by row. So I wrote a mathematical program to do it. And it turned out I had to be a little bit cleverer than I had expected to be to get things to run in a reasonable amount of time. Just doing n choose k when you're in row 2000, these can be very hefty computations. You have overflowers. You have to be very careful about how you do it. And so it's an interesting question to think, what is a good way to arrange the computations to get things done in a reasonable amount of time? Often when you take math competitions, there are brute force ways to solve the problem that are designed to require more time than you have to do the competition. I was fortunate to take 3 classes from Peter Jones at Yale, and I remember doing one of his problems, and I had a way that I knew would work. And after writing 2 or 3 pages of calculations, I wrote, this is ridiculous, there has to be a better way. And he wrote in the margins, it's about time you realize that, Steve. And then the problem was solved in 2 or 3 lines. I knew this computation would work, but it would not work efficiently, it would not work elegantly. On an exam in class, there's going to be an efficient, elegant way to do it. How many of you have taken multivariable calculus? Again, hand should all be up. How many of you have done Green's theorem, Gauss's theorem, Stokes' theorem? So one of the tricks that's often done in Calc 3 is if we give you line integrals or stuff like that early in the semester, we choose situations where we can use Green's theorem and you easily calculate the answer and then just check and make sure we're giving you the correct answer. As you often want to have nice ways of doing problems. All right, so this is probably a good place to stop in terms of what we've covered today. I don't mind stopping a minute and a half early. Are there any general questions about the class? Yes?
Are you going to have problem sets due every class then?
No, I'm going to, I like to have problem sets due every class in Calc 3 because the students really need the structure. For a class like this, I would much rather have the problems due essentially once a week. So I'm thinking probably Fridays is going to be when the problems are due. So the first homework assignment, the problems are not too bad. You have to read my favorite graduation speech. Okay? And so everybody hears a graduation speech. Well, everybody who graduates hears a graduation speech. This is one of the best ones I've ever heard. It's filled with a lot of great advice. I want you to read that graduation speech and tell me what you've learned from that. I want you to send me a brief paragraph about why you're in this class and what you want to get out of this. The more I know about you, the better chance I have of making this a pleasant experience for you. Also, of course, feel free to come by my office, email me, we'll grab a coffee or something so I can get to know you better. Other homework is I want you to read a short note on proof techniques, just some of the standard ways of proving things. I want you to read pages on induction, and I want you to do that by Monday so that on Monday we can actually have a real honest-to-goodness lecture. Okay, other questions or comments? Yes?
Just going on that list, there's one for problem questions.
Yeah.
Yeah. So I don't know what the questions are, but assuming that they're designed to be tough.
Yes. No, I mean the Putnam questions are designed to be extremely tough. Have you seen the movie Men in Black? There's a great scene when we're here to find the best of the best of the best of the best, sir, with honor, distinction. This is what the Putnam is. It's to separate the best of the best of the best of the best from the best of the best of the best of the best of the best. I wish the Putnam had at least one friendly question each year, but that's not a given. I do know people who write who write Putnam questions and are in charge of the committees, and their view is that there's enough competitions out there that are designed to keep people happy, that the Putnam has a very special place. And so one last note is the very first math monthly dinner is going to be this Monday at 5:30 in Mission.